So before we start the notes today, we're going to revisit this. You don't have this in front of you. You don't need it in front of you, okay? When we very first started Unit 3, before we even knew this was a sinusoidal function, I gave you all these at your tables, and I gave you ordered pairs, and we put them on there, right? To make sure we all understood that X goes from left to right, least to greatest, and Y goes bottom to top, least to greatest. And we're going to do a lot more of these examples. And you're not given the ordered pairs like I have here. But something came up on one of the assignments. Somebody asked me a question. I don't know which section it was because it all starts to look the same. I mean, a lot of your assignments just kind of look the same. I just know it was pink. But either way, this kind of thing shows up on a few of your assignments. But she had a very good question. So let's just talk through this because one of these situations has not come up yet, but it comes up on the assignment, and I don't want you to be totally stuck. So if I look at the ordered pairs, I have them written down where the X values go from least to greatest, okay? I have 5 ordered pairs, but there are an infinite amount of ordered pairs that I could actually put on this curve, okay? So the 5 I have up there are not necessarily F, G, J, K, and P, all right? But what I know when I look at this, okay, yes, I'm going from left to right. Do you think the first point being 0, 0 would make sense? No. Okay, and see, that's why I think some people started getting the Y values and everything else. No, because 0, this is not my smallest Y value, right? I'm sorry, not my biggest Y value. This is. And this is my smallest Y value, right? So I'm going to look at my Y values first. And I have a maximum value of 3, a minimum value of -3, and then I have these 3 zeros. So even though I only have 1, 3 written down up there, I have 2 points up here that would have a Y value of 3. You agree with that? This one would have a -3, and these would be 0. Okay, that's just from my Y values. So then when I go up here to figure out where I'm going to put 0, 0, 0, 0 cannot go here because I have to give ordered pairs for F, G, J, K, and P that make sense in the problem situation. And although these problem situations change, the input is going to be time on every single one of them. If this X value is 0, this X value would have to be negative, right? Can you have a negative time? No. So I can't put it here. I have it's on the, oh, well, then I put a bunch of stuff back there. Just sit at a different table. There you go. So I can't shift it to the right, but I know it has to be on the midline, right? Because it's a 0. So if I back it up, I know that this point, even though they didn't ask me for it, we have added some points on some of these, and sometimes we have to do that. I know that this Y value would also be 0. Then I have to ask myself, would it make sense for this point to be 0, 0? Based on the other points that I have. Because remember, these are in order, right? So after 0, 0, I have to be able to put this point. So after 0, 0, the graph goes up to 3. It doesn't go down to -3. You with me? That's how I know it can't go there either. So if I continue my graph, I have a point there. Obviously, that's not 0, 0. That would have to be something -3, right? And then I come back up. And then this I know would be at 0 again. Would 0, 0 make sense here? If I make this 0, 0, my next X value is 5, so that's 5, -3. Then I would have 10, 0. Then I would have 15, 3. And then I would have 20, 0. And then what would this be? 25. And this would be 30 and 35. Okay. Does that make sense to you? So sometimes you have to back up. You might only have to back up to here. You might only have to back up to here, or maybe you shouldn't have to go farther than that. And or maybe by the points you have, you can think about starting forward. Like if it wasn't 0, 0, maybe I could have started over there. But I don't get to have negative time. So my actual points for F, G, J, K, and P would be these 5 that I have labeled there. Okay. So if you get to that and you're still confused, I can help you through it. But I felt like at least just mentioning it in class, it would get probably most of y'all past that on your assignment when you get stuck and wonder what the heck you're supposed to do with it. Okay, we good on that? Awesome. All right, let's go here. We're going on page 91 when we're done. All right, so this is sinusoidal function context and data modeling. So usually when the topic sounds like that, we're doing some sort of regression. And we are eventually, but there's all other ways to look at it besides just punching stuff in the calculator. We're not going to do that for a while. But we've looked at different ways to construct different methods to construct models. We're going to put it all together so we can do function models for sinusoidal functions. We've already seen that a sinusoidal function can be written like this, or in a similar form with cosine. So remember, if I have a sinusoidal curve, like the one I just saw or the one you see right here, I could write an equation for that. The equation could be cosine or it could be sine, because it just changes by a horizontal translation. That's it. So let's look at this first example. It says, let f be a sinusoidal function. The graph of y equals f of x is given in the xy plane. What is the period of f? So what do I always say is the first thing we should look for? Midline. Okay, so I'm going to use my handy dandy collar over here. And Antonio, tell me, where would the midline be? -2. Okay. Now, when I said where would it be, and he said -2, that is a perfectly fine way to say the answer. What if, Antonio, what if I said, what is the midline? What would you say? Y equals -2. Very good. You see how when you ask it differently, you can answer it differently? All right, so y equals -2. All right, great. And so then it's a sinusoidal function. It does not say in here specifically sine or cosine, but even if it did, it wouldn't matter for me to find the period. The period, I need to find the beginning and the end of one cycle. I could look at this as cosine and start here and end here, but I'd have to guess at my x value, so we definitely don't want to do that. Also, if you can start at 0 or start on the y-axis, that's ideally what you want to do. So if I start here, I'm starting on the midline. This is one cycle. And then tell me, Daniela Camarillo, what would the period be? 2. Okay. Your answer is 2. Now, this should look very similar to one you did on Albert yesterday, or even that we did in the notes the day before. The difference here, and the reason it's in this section, because we've already talked about period and stuff like this, is if you notice your x-axis doesn't have pi fourths, pi halves, 3 pi halves. It has 1 and 2 on it, which when we're actually doing applications of this, a lot of times the inputs or the angles, those are still radians, but they would be like the decimal form, because when you apply it, you're actually typing it in to get real numbers. So your inputs could be whole numbers, they could be fractions, they could be decimals, or they could be the angles we know, like pi halves, pi fourths, pi thirds, whatever. Okay. All right, any questions? Awesome. Let's look at this one. So it says, let g be a sinusoidal function, where we get that right there. Okay, so the only unknown there is c. So tell me, Daniela Hernandez, what does the c do? Horizontal translation. So that c is going to move it left or right. So the vertical translation is already taken care of, the period's taken care of, and a is 1. So this is cosine. Here is my generic cosine, right? And when I look at these, if c is 0, that means that I don't translate it left or right at all. Has this been translated left or right? Yes. Or if I say no, it hasn't been, but if I start here, I look at this, how could I change this without a translation so it would actually be that graph? Not the -2. You see how it's upside down from this? It's a reflection in which axis? The x. So if I just put a negative out front, the negative cosine would reflect it. And because if I made it a sine, I'd also still have to shift it. But I could make it a sine also, but for that specific thing. But it's not reflected, and so that's not my answer. Okay. Now, this whole c thing stresses me out because I don't like the way they did it. So I would suggest to you, because this is what I do for myself too, because it's not necessarily difficult, but it's really easy to mess up. Since this is a positive pi fourths, when I substitute it in there, I'd have x plus pi fourths. Like I'm literally going to write that out. And then I'm going to look at that and think about every transformation I've ever known and know that that takes me in which direction? To the left. Okay. So going to the left. And I was hoping yesterday when y'all practice on some of this, it would help you. And we did a couple the day before, but I know the whole translating thing and figuring out the graphs is still kind of sketchy for some people. So I want you to think about this graph here. This is before we translate left and right. This is after we translate left and right, okay? And this is my midline. So I'm gonna go ahead and put that guy in. Can't believe it took me that long to do that. I usually do that very first thing. So now this is my midline, right? My midline is like my new x-axis. So if I'm doing cosine, I am starting on the y-axis at the maximum above the midline. This is before I translate. So I'm starting here. And then I'm going to move to the left pi-4ths, which puts me right there. If I take this graph and shift it to the left pi-4ths, it does not look like this graph because I didn't make it far enough. You with me? I'm not even touching the graph, so I don't like that one. That's a positive pi halves, so this is going to be x plus pi halves. That again tells me I'm going to the left. So once again, I'm starting at the maximum above the midline. I'm going to move to the left pi halves. So that's good so far, but that doesn't guarantee me this. Since cosine is positive right here, that means just like this, I'm going to go down and then come up. This one goes down and then comes up. I like that. So I like C. Okay. And I don't have to check the period or anything because they're all going to be the same because they gave me the equation. Then I'm going to look at this one. This is x plus pi. So that means I'm going to the left pi. So again, I start here. I move to the left pi, not even touching my graph. So I don't like that one either. So C is my answer. What questions we got? Anything? All right. Here's another clock question, but it is a different clock question. All right, so a clock is mounted on the wall, and the point P is located at the tip of the minute hand of the clock. All right, so I'm going to draw myself a clock here. So here's my clock, and it says point P. Wait. Point P is located at the tip of the minute hand. Okay. This is point P, and then P is going to rotate around like that. Pretend like that's the middle. It's okay. Good enough. Then here is my equation. It tells me that points 0, 70 and 8 and 30, 52. Okay, so I have those 2 points, but the next part's important too, represent a maximum and a minimum value respectively. Okay, so it's not like just like I have these random points. P starts up here at 0, 70. It's going to get down here to 30, 52. Okay, and I need to find A and D. So I'm going to draw some stuff, but I'm going to show you on this one that you don't even have to always draw everything out. I'm going to end up drawing it all out because I want to talk about some other things, but we don't have to go all out on every single question. So here is a little graph. I know I'm going to have a point. I need a 70 for a y value, and I need a 52 for a y value, and I need a 0 and a 30. And again, I'm not even going to plot my points yet to show you I don't necessarily have to if I can wrap my mind around everything that's going on here. So I need, so just like with an equation, or just like with a graph, with an equation, the first thing I'd like to look at is D. And Alexa, what does D represent in my function? Yeah, it's okay. I know it's the pressure. You can help her. The midline, good. D is the midline. So this right here, that's D, right? So how do you think, because there's more than one way to do this, and we'll talk about both, but what could I do to figure out where that is? Who wants to give me an idea? Add and divide by 2? Okay, so we're going to add 70 plus 52. That's going to give me 122. I divide that by 2, and what do I get? 61. So that means I'm here at 61 on the y-axis, right? And that represents the location of D, so y equals 61. There we go. Now, A is very much related to D, right? What do I do to figure out A? Count or subtract, absolutely. 70 minus 61 or 61 minus 52. I think 70 minus 61 is easier, but there's 9. And you know what? Go ahead and do this one too. That's an easy way to check to make sure your midline's really in the right place, right? And you get 9. Now, the way I heard it, so earlier today when I said, what could I do to find D? Somebody told me to subtract and divide by 2. Okay, so that's what we did. 70 minus 52, that gives me 18. And then I divide that by 2, and I get 9. So when I do that, when I subtract them, I'm finding this whole distance here, which is 18. We divide it in half, get A first, and then once I have A, I can find D. So whatever makes the most sense to you, how, just so you can find the distances and know how they're related, one's not necessarily better than the other. Okay, everybody good so far? Now, I didn't even plot the points, right? I didn't necessarily need to. I could have, and like I said, I'm going to because I want to talk a little bit further in this question. But if I was to plot them, I have 0, 70, and then 30, 52, that right there. This is a sine function. My sine parent function looks like this. So on this parent function, if I had to figure out what in the world I even had, then I have a maximum and a minimum. That means I have this point and this point. That makes sense to you? Halfway between those two, I have a point on the midline. Halfway between 0 and 30 is 15. So I have a point right there. See how that works? And you see how referring back to this can help you keep track of where you are in your function? Let's say they asked me for C, right? Then I would need to know how much I translated it. Would it be easier to think about this as a translation to the left or to the right, do you think? It's a matter of opinion, really. But the way I see it, if I draw this part in here, I can finish this up over here, right? And this would be at what? Where would that be? Negative 15, right? Because everything's evenly spaced. And then that gives me this point. So then now I can see that from here to here, that's 30. So the period would have to be 60 because that's half of it, right? And then I would have to move to the left 15 in order to get there, okay? So you could still keep drawing it in there, even just with 2 points. If it's 2 points and you know where they are, you can figure out everything. You can figure out all the other points, okay? But again, it didn't ask you for that, but I wanted to talk you through it. Ask me questions. What questions you got? We good? All right, I'll flip it over. So this prompt is very much like the FRQ, but it can also show up on a multiple choice for sure. So this says a yo-yo is attached to a 30-inch long string is rotating at a constant rate. The figure provides a representation of the yo-yo in the XY plane with the direction, the rotation indicated. At time t equals 0 seconds, the yo-yo begins to rotate. It's at the start position. So this right here, this point is going to be at 0. And then because it's on a graph, I can see that's at negative 30. Right? Then it says at time t equals 5 seconds, the yo-yo has completed 20 rotations and is in the same position. So that means at 5 seconds, I'm still at negative 30. Okay? A sinusoidal function is used to the model. Which of the following functions in an appropriate model? Okay, so before I do anything else, I'm going to look at my answer choices and see what exactly I have to figure out, because I don't have to figure out everything. A is the same on all the answer choices, so I'm pretty sure it's 30. There is no B and there is no D, so really, I'm sorry, there is no C and there is no D. So B is really all I have to figure out. And then tell me, Alondra, what is B related to? What do I have to know about my function to find B? The period, exactly. So I need the period. Well, I know that I'm going to start at 0, negative 30. Now, I'm going to draw this, and I'm not going to draw enough, I know, because I'm not even going to count. But I have, when I get to 5 seconds, I've gone through 20 rotations, which means 20 cycles of the squiggles, right? And so let's just pretend like this is 20, okay? Just pretend like I got 20 cycles, just so we can wrap our mind around it. So if that's 20 cycles in 5 seconds, I need to know how long it takes just for one cycle. So what could I do here? It's not 5 seconds for sure. How many cycles in 5 seconds? 20. So what do you think I could do with that 5? Divide it by 20, right? So I'm going to take 5 over 20, because 5 seconds for 20 cycles, that's going to reduce to 1/4. Now, in second period, God bless those children, because I have many moments in there when my brain isn't functioning. And after I did this question, we had moved on to the next one. And in my mind, I thought, I think I did that wrong. I think it's supposed to be 4. And I looked back at my notes and I was like, that's not the way I did it over here. Surely I made sure I was right. But like, I couldn't get past it. So I was like, I can't come back tomorrow and do confessions of a bad teacher again. We're going to go back and revisit this together, and we're all going to think together. So I think part of my problem was I was saying 5. I think I was saying 5 cycles for 20 seconds, but it's 5 seconds and 20 cycles. But either way, if you get yourself into that and you're like, I got 1/4. Is it 1/4 or is it 4? Whether it's this or really literally anything, to me the picture helps, because if this is 5 seconds, there's no way that at 4 seconds I only have one cycle when the whole thing is 20. You with me? So clearly 4 makes absolutely no sense. And I know that doesn't even look like 1/4, but 1/4 of a second makes a lot more sense. So, if you get yourself into that, because you do, I know you do, because you start to, then you question everything, right? Find some way to make it make sense to you. All right, so my period is 1/4. When I go to find B, what always goes in the numerator? 2 pi. And then I'm going to divide that by 1/4. And then I'm not going to freak out that I have a fraction and a fraction. I'm going to keep change flip. So that's 2 pi times 4 over 1. So B is equal to 8 pi. Here is B as 8 pi. My answer is D. What questions do you have? Okay. Notice I didn't have to worry about anything else but the period. So look at your answer choices so you're not trying to, figure everything else out when you don't need to. All right. Modeling data from analytical information. So the average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by this sinusoidal function. Based on the model, which of the following is true? So it's talking about maximums and minimums, what they are and where they are. This is a non-calculator question, so I think I need some sort of picture to help me with this. So we're going to sketch out a little graph here. Again, we don't have to go crazy. But again, what is the easiest thing for us to find first? Midline. Okay, so I'm going to say, all right, here's my midline. That looks good. That is at 61.2. All right, and I know that it is a sine function. And I want to know if my sine function got translated left or right. Averill, tell me what you think. Right, very good. That's a -4, so we're moving to the right 4. Your parent function for sine looks like this. Okay, so I'm going to move to the right 4 to start. Here is 4. So I usually start it on the midline at the y-axis, but I'm starting over there at 4. It would be really helpful if I knew where I ended. In order to do that, I need to find the period. I have B right here, right? So to find the period, I'm going to do 2 pi divided by pi over 6. And then again, I'm not going to freak out that I have a fraction and a fraction. I'm going to keep change flip. 2 pi over 1 times 6 over pi. And what does that give me? 12. So the beginning here is at 4. The end here would be at 12. The end here would be at 12. Both on the midline, right? And then I'm going to refer back to my little sketch because I know if this is the beginning and this is the end, halfway between the two, I have another point on the midline. What's halfway between 4 and 12? 8. So here at 8, I have that point there. See how that works? Then, because this is sine and it's positive, so I know I'm going to go up first, halfway between these two, I have a maximum. So halfway between 4 and 8 is 6, and I'd be up here at a maximum. I don't even know what it is yet, but it's fine. And then halfway between these two, I have a minimum. So halfway between 8 and 12 is at 10. Here's my minimum. See how easy it is to get those 5 points on there? All right, so then I'm going to go ahead. I mean, you wouldn't necessarily have to, but I'm going to sketch it so I can see something. It's okay if it's all wonky and off scale. Totally fine. All right, so let's start reading our answer choices here. The maximum average monthly temperature is 61.2 degrees. What do you think? Nah. And if all you did was draw in that midline and didn't write 61.2, you might not catch that right at first, right? So that can't be because that's my midline. Maximum average monthly temperature occurs at 1 month. Well, we don't even have 1 month on our graph yet, so let's just wait on that. We'll come back. Minimum average monthly temperature is 35.5. Not sure what I would do with that yet, so we'll wait on that one as well. Let's look at D. The minimum average monthly temperature occurs at 7 months. What do you think about that? No. When does it occur? 10, okay? So that's a no because it occurs here at 10. All right, so let's go back to B. It talks about 1 month. So just kind of like what we did earlier, we're going to back up some, meaning that if we're counting by twos here, right? So then at 2, if I start going to the left, then I should have a minimum there, right? And then when I go back up at 0, I should be back on the midline. And I could continue going if I had to, but I don't need to. I can now see, do I like B or not? No, the maximum does not occur at 1 month. Neither does the minimum. The answer is not B. So we hope to God we like C, right? So minimum average monthly temperature. Well, I have that 61.2. What can I do with that to see if I can get 35.5? What else would I use? Well, besides 61.2, what would I use? The what? The amplitude, exactly. I want to know what this temperature is. This is my amplitude, right? I know that value. That value is 25.7, right? That's the distance there. If I subtract those, you will get 35.5. Okay. What questions you got? In worst case scenario, the other 3 absolutely made no sense. So, pretty confident it's C. But I've marked all 4 of them out many times before. Any questions? All right, so now we have the function n gives us a number of nighttime hours on the first day of the given month, where t is between 1 and 12, gives us values of n at selected values of t. A sinusoidal regression, like this, was used to model these data. What is the maximum number of nighttime hours predicted by the sinusoidal function model? Okay, so we need to go to Desmos, type in your information into a table. I got smart and didn't shut mine out. Where's your computer? Huh? That wasn't my question. Where is your computer? Okay. Once you get it in there and you hit regression, and let me hit my little, what kind of regression do we want? Sinusoidal. See, it says it right there. And then I'm going to hit my magnifying glass, and there we go. Okay. All right. So now look at the equation that it gives you. God, every time I click on it, it jumps back down. The excuse me. The equation that it gives you your A, it gives you your B. This really isn't C, because in order for this to be C like we understand C, B would have to be factored out. We'll kind of look at that again. And then this is D. So got all that stuff. Once you do that, before you touch anything else, I've got green points and I've got gray points, right? And once I touch something, some of them go away. The green ones are the ones I typed in. The gray ones are important points that I might need to know. Here's my y-intercept right there, right? Here, it's really close to this green one, so to make sure that I'm actually clicking what I think I'm clicking, I could zoom in. Now, when I did that, they went away, but if I just touch my my function in again, it'll come back. So there's my maximum, there's a minimum, and then those will stay there until you move it or do something else. So if you don't want to have to keep clicking on that stuff, you can export these so that you don't have to come back and find them 1,000 times. Now it doesn't even want to cooperate. Okay. Like if you needed them. And I don't even know what's happening over there now. Did this one? I thought I clicked that. Maybe I didn't. Either way, like you don't necessarily have to, but then the numbers are there in case they disappear on you and whatnot. It even gives them little colors. You can even label if you needed to, but there's really no need for us to get that fancy. All right, we'll talk about what the question's actually asking in a minute. But if it did ask me for the amplitude, would I have to use my graph or could I use my equation? Equation. So tell me, somebody, Angel, what is the amplitude? Exactly, it's your A value, right? What about the period? Would I have to use my graph or could I use my equation? I could use the equation because remember, just like we have before, to find the period, it's 2 pi divided by b. I could totally do that. But let me just show you a different way because, you know, it's good to have different things if that confused you or you weren't sure. Since this is sine, it's difficult to find sine with the period if I don't have my midline. But I know where my midline is, right? So tell me, Camille, where is my midline? 8.215, that right there. So let's come in here and let's do y equals 8.21535. Oh, well, it would help if I actually did the right thing. 21535. There we go. So another way to do it, right? One's not necessarily better than the other, but just like we did before, if I say, okay, I'm going to start there, let me export that point, and then one cycle would end here, and I'm going to export that point, then I'm looking at these two, and if I want to find the period by using these 2 points, would I be looking at my x value or my y value? X. And basically I'd take this, it's 9.4 minus the negative, or you can think of taking the 1.6 and adding it to the 9.4, like whatever. But that's just a different way to do it, okay? I could also find the amplitude with subtractions, but we don't need to do any of that. And then I know what C is. B, C, C, I know what C is. But think about it. C, if this is at negative 1 point blah, 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 then that means C is a positive 1.61 whatever. You can find it that way. You don't have to actually factor that out. So just wanted to talk you through all that because on the question we're actually on, technically we could have gotten a pretty good guess without even doing this, but on the other ones, you need to understand how to look at this stuff on here. So let's go back and look at this. And then I'll talk about the whole BC thing again. Well, let's go back over here. Actually, I gotta need my answer. I put these, this was my minimum, this was my maximum. So my maximum is at 11.33, and this was asking for the maximum number of nighttime hours. I don't love this question because I feel like these answers should be in decimals because you're not getting an exact number, but our answer would be 11. If you understood that this is sinusoidal and you look at your answer, you look at your data here, you've got 11.4 and 11.3 as your maximums. You know, this kind of is my minimum, and then this here, like my in between, and you understand that it's going like this. So based on this, we're looking at closer to 11 than 12. So like I said, could have done a pretty good guess, but we can't always guess on them, so we don't want to worry about that. But do you see how, look at this, where it told me this is what my calculator is giving me. Notice on all the other ones, well, you can't really see on that one because I've written all over it, but let me find. Here, you see how B is factored out? For C to act like we understand C, B has to be factored out. Otherwise, there's other ways to look at it and think about it, but that's not usually how we do it. So I don't think you're going to do a regression on Desmos and then ask you about C. I just don't think nobody's trying to trick you. Okay. What questions we got? Anything? Awesome.